So good afternoon, everyone. Welcome to the Economic Club of Florida's 578th meeting in our continuing series of distinguished speaker programs. I am Katrina Roll, and I have the privilege of serving as your club president this year. I hereby call this meeting to order. So we have another exciting and informative program for you today. Our guest speaker, Dr. Nilüfer Ertekin-Taner, I have practiced it and she told me I nailed it, is a distinguished physician scientist renowned for her groundbreaking contributions to Alzheimer's disease and related neurodegenerative conditions. Dr. Ertekin-Taner's exceptional leadership and expertise have garnered significant recognition, including prestigious awards such as the 2022 Alzheimer's Association Zenith Fellows Award. Our Economic Club of Florida board member, Karen Moore, will be introducing her shortly. But first, a quick reminder, our May meeting is being finalized, so please be on the lookout for those details. But do add June 25th to your calendar. Clark Micah with the Institute of Makers of Explosives will be our luncheon speaker. We were trying to get it for July 4th, but it didn't work out. But I also want to say that if you all know of any speakers that you think would be really good for our club, let us know. We often get some of our best recommendations for people who are members of the club. Also, good news, we're going to be aired on WFSU for our meetings. Details will follow. Lisette, Mariner in the back, will be sending that out, letting you know the time. So you don't want to mention our luncheon programs, and please continue to check the website. So I'd now like to recognize our trustee members. Our club trustee members provide additional financial support to the club each year, and in turn, they receive exclusive benefits such as attending receptions with our speakers and having an opportunity to speak with them in a small, intimate setting. And they did so today with Dr. Ertekin-Taner. I'm so proud of myself that I got that right. So our trustee members are also invited to attend other local events that we host from time to time. If you are a trustee member, would you please stand and be recognized? Thank you. So I'm told we have a number of guests today. Welcome to all of our guests. We're going to ask for all of our guests to be introduced and ask that everyone hold their applause until everyone has been introduced. Since I'm presiding, I do want to introduce two people on my team, and I know my CFO is looking like, no, she better not. So Lucia Fontella and Cheryl Crumpler, would you please stand so you can be? Okay. Anyone else that's a guest at that table? No? Paul, anybody at your table? Here? Any guests? Please stand. Oh, awesome. Welcome. Wait. So y'all did not follow directions, but I think because she's a young woman and we're very impressed with her, we clap for her. So yeah. All right. Thank you, Molly. That table over there, anybody? New? Yes? Oh, thank you. Okay. This, Steve, anybody at your table? Yes? This table? Yeah. Awesome. Forget about it, right?
Yes.
Oh, good.
John Pavetta is with Alzheimer's Project, and Courtney Potts, the Courtney Potts, is with Alzheimer's.
Awesome. This table? Anybody? Oh, right here. Sorry. Awesome. Bernice, anybody at your table? New? Guess? Any guess? Bobby? Awesome. John? Barney, anybody, any guests at your table? Is- Bill, any guests at your table? This table? Did I miss anybody? Did we cover everybody? Okay, well, welcome to all of our guests. We hope that you guys will consider membership. There are applications at the table with Rachel and Stephen, and they're also on our website. And so now I'd like to introduce the head table. I was going to say again, hold your applause, but we'll see how it works out. First, Karen Moore. A member of our board, Karen is a national leader in the media relations, public relations, crisis communication, and public affairs arena. As noted by Henry Kissinger, Karen is one strong lady. She has been named annually by the Florida Trend as one of the 500 most influential people, or influential Floridians, and the top 150 most influential people in Florida politics by Influence magazine. Karen was recently named the 2023 National Entrepreneur of the Year by PR News, and her book, which I have a copy of, Behind the Red Door, Unlock Your Advocacy, Influence, and Success, was listed on Amazon's bestseller list. She and her husband, Richard, recently visited Antarctica, and if you follow her on Facebook, she did a really great job of helping you go along the journey with her. But as an avid world traveler, she has visited 103 countries and has eaten rotted shark in Iceland and fried rat in Cambodia. But we still love her. We still do. Okay, Robert. I practiced his name. I might not nail it. Robert Descartes. Okay, thank you. Robert is a senior IT thought and sales leader based in Tallahassee. He is renowned for driving business growth through technology leadership, innovation, and customer-centric strategies. Robert has a track record of success in senior leadership roles at some of the largest IT companies, including NTT Data, where he currently is, Salesforce.com, and AT&T. And he's also worked in the public sector with the Florida Supreme Court and the Second Judicial Circuit. He excels in building and leading high-performance teams, establishing brand new services, and forging trusted relationships with clients to deliver exceptional outcomes. With strengths in strategic planning, communication, and a relentless drive for results, Robert is a dynamic force in IT and sales leadership in the Southeastern United States. Dr. Larry Kubiak. Larry's extensive career in psychology spans decades of impactful service and leadership roles. With a PhD in counseling psychology from the University of Florida, which he's very proud of, he has conducted over 12,000 psychological evaluations as a director of psychological services at the Tallahassee Memorial Behavioral Health Center. His contributions extend beyond clinical practice, as evidenced by his tenure as an adjunct professor at Florida State University and leadership roles in professional associations, including serving as president of the Florida Psychological Association. Additionally, Larry's commitment to community service is exemplified through his involvement in the Boy Scouts of America and Rotary International, where he has held positions such as district governor and mental health advisor. John Ferguson. John is not only the president and chief operating officer of National Stormwater Trust, a pioneering stormwater management company based in Tallahassee, but also a distinguished Navy veteran with 28 years of service as a naval officer. I told him he looks really young to have 28 years of service. With extensive leadership experience, including commanding a guided missile destroyer, John brings a unique blend of expertise in both environmental stewardship and operational excellence to his role in advancing stormwater treatment services across Florida and beyond. Please welcome the head table. And now I invite Karen Moore, a world traveler, to introduce our featured speaker.
Thank you, ma'am. I did eat fried rat, and it still had the whiskers on its face. I'd like you all to take a moment and think about these numbers. The estimated cost of Alzheimer's in the US last year was $305 billion. Currently, there are more than 6 million Americans suffering from Alzheimer's and related dementia diseases, 600,000 of them right here in our state. And some studies show that that number of individuals living with Alzheimer's will double every 10 years, which means by the year 2050, we will see 88 million Americans living with this dreadful disease. Now, because we're the Economics Club, let me put an economic impact number on you. It's estimated that the state of Florida in that year, 2050, which is just 26 years from now, our legislature will have to budget $1 trillion that year for the cost of care for people in our state suffering with Alzheimer's. So you are in for a treat today. We have one of the world's leading neurogenetics and behavioral neurologists here to speak to us. She has both an MD and a PhD. We have Dr. Nilüfer Ertekin-Taner, a pioneer in the use of amyloid B peptide levels as an endocrine type of Alzheimer's genetic research. So let me stop and say, I have a degree in Russian history, so I have no idea what any of that means. But I think what it means is that what she does is she leverages complex data to uncover genetic factors for these neurodegenerative conditions. I do want you to know, not only do we have a world-class researcher here with us, it's a power couple because her husband is in charge of all transplants for Mayo worldwide. Her expertise is very near and dear to my heart, having lost one parent to Alzheimer's, the other parent to dementia-related circumstances. I can tell you, as many of you in here know, what it takes for caregivers to have increased health risks dealing with the stress of this disease. But I do want you to know she is mortal, like some of us in here, because she came here today, having been yesterday in Savannah, Georgia, where she spoke on the stage, get this, 2 living legends, Renee Fleming, the world-famous opera singer, and our speaker today, both talking about a special issue dealing with the brain. Perhaps you'll share some of that information. Speaking on this important topic, please join me in welcoming Dr. Taner to the Economics Club of Florida.
Wow, it's wonderful to be here. Thank you, Karen. I'm excited, delighted, humbled, and thank you for having me at this wonderful forum. So today, I'm going to talk about hope. I'm going to talk about science, and I'm going to talk about a lot of scientific data, but please don't leave the room just yet, because I'm going to talk about how it relates to all of us. As scientists, as physicians, we have an obligation to share all of this with all of you, and I'll do so at a very highly functional layperson level. And please feel free to ask me questions afterwards. I think we'll have time for that. Okay, so this is my team at Mayo Clinic in Florida. We have over 20 investigators in my lab. The work that I'm going to talk about is their work, as well as the work of the Department of Neuroscience, which I chair for the enterprise. We have over 250 scientists and trainees at Mayo Clinic in Florida, where our collective mission is to find cures and diagnostics for currently incurable and undiagnosable neurologic illnesses like dementias, like Alzheimer's disease. And the work that I'm going to talk about cannot be even done by a single institution. And so I want to acknowledge the phenomenal collaborations that we have across the United States as well as across the globe. I'd like to acknowledge the fantastic funding support that we have received through the years. This funding support, as you see here, includes the Florida Statement of Department of Health, and I'll say more about that down the line. So you can see the return on investment that those very precious seed resources has on Alzheimer's disease and other types of research. So today, I'm going to talk about a tale of two neurodegenerative diseases. One of them is Alzheimer's disease. That's the epidemic of our century. The other one may not be as well known, but still a tremendous burden to the patients, to their caregivers, and to society, a condition known as progressive supranuclear palsy. And I'm going to talk about these two diseases because they're both complex. They're heterogeneous, meaning that each person gets these diseases for their own set of reasons, even though we call it all Alzheimer's disease or progressive supranuclear palsy. Each person has their own risk and protective factors. We have no or limited disease-modifying therapies for these conditions, and both of them have a long prodrome, which means that by the time I get to see a patient in my office and I get to diagnose them with Alzheimer's disease, they had the disease in their brains for 20 years or more. And studies have shown that the risk, some of the risk, the genetic risk, may be there from birth. So that means we have an opportunity for intervention. Yes, it is a problem, but we can turn that problem potentially into a benefit for us if we think differently about it. We each have an opportunity and a responsibility to maintain our brains, and I'll say a few words about that as well. So let me start with the less well-known disease, progressive supranuclear palsy. It is a Parkinson's-like disease, but it's different than Parkinson's disease. It's far faster progressive. It has a younger age of onset. It's thought of as a rare disease, but that may also be because of underdiagnosis. We see a lot of patients at Mayo Clinic with this condition, and it has a huge impact. Most of the patients become incapacitated. They become almost locked into their bodies. And the even more tragic aspect of it is most of these patients retain their cognitive abilities despite that. I'm also today going to talk about brain signatures of these diseases because it's really important for us to think about that and think about how we may reverse the perturbations in the brain. So progressive supranuclear palsy affects almost all brain cell types in our brains. It leads to accumulation of an abnormal protein called tau. I'll come back to tau. So Alzheimer's disease is the most common type of dementia. So what is dementia? Dementia is the umbrella term. It means a person is having problems in their thinking and it's interfering with their day-to-day life. Not all dementias are Alzheimer's disease. Alzheimer's is the most common kind of type of dementia. And we already heard how common it is. 7 million Americans living with it, more than 40 million globally. The numbers are going to escalate if we do not find a cure for it. Now, Alzheimer's disease has a specific signature in the brain. It also has the tau protein, as does PSP, progressive supranuclear palsy. So a potential commonality there. It's got this other protein called amyloid beta that Karen alluded to, that we, for the first time at Mayo Clinic in Florida, used as a phenotype to uncover genetic factors for Alzheimer's disease. So the economic impact, Karen already touched upon it. The official number is $345 billion in 2023. That does not count the cost of caregiving. Just in 2023, there was more than 18 billion hours of caregiver time allotted to caring for patients with Alzheimer's disease. We cannot even imagine the economic impact of that. And Florida has the second highest prevalence of Alzheimer's disease in the country. Currently, approximately 600,000 Floridians above the age of 65 has Alzheimer's disease. So that's 12.5% of our residents. It's an astounding number if you think about it. And the number of Floridians serving as caregivers for patients with Alzheimer's and other dementias, you see the numbers there. And that is an increase of 13,000 caregivers just last year. So that is estimated to 1.3 billion hours of unpaid care. And that's a value of almost $25 billion in additional burden. Of course, none of us can measure the humane burden of this disease, but these are the numbers, the financial numbers. Okay. So how do we counter these diseases? Well, the way to combat the enemy is to know the enemy, right? So we need to know about these diseases, and genetics have taught us a lot. So I'm going to show you some numbers here and some text. I'll explain them. For progressive supranuclear palsy, as well as for Alzheimer's disease, we have been able to look at the genetic alphabet of tens of thousands of patients, and that gave us information about potential risk factors. In PSP, we call them as GWAS loci, genome-wide association loci. Basically, think of it like the address, the general address where there is a fire. So the firefighters are called and we say there's a fire in this general region. That's the kind of information that these kinds of studies give us, but they don't tell us exactly which house is on fire, and they don't tell us what caused the fire. So I'm going to talk about the studies that actually lead us to the very house and the cause of the fire. So this is progressive supranuclear palsy. And then for Alzheimer's disease, we know a bit more about its genetics. This may be surprising to learn that Alzheimer's disease is not only a disease of the older individuals, but there are, albeit rare, forms of Alzheimer's disease that also afflict young people, people in their 30s and sometimes even in their 20s, if they carry specific big typographical errors in their genetic code. We term these as early onset familial Alzheimer's disease. And the past 20 or so years of Alzheimer's genetics have identified 3 genes that have those typographical errors that lead to young onset forms of Alzheimer's disease. And then these big GWAS studies have identified over 80 general addresses of the genes that are risk factors for Alzheimer's. But again, they don't teach us necessarily how we get from those genes to the disease themselves. So we might ask ourselves, now that we know about these genes, why don't we have more cures for Alzheimer's and PSP? And the answer again lies in the economy. The cost of putting a single drug in the market is on average over $1 billion. So pharmaceutical companies cannot commit unless those drug targets are de-risked for them. And the groups that are going to really identify those drug targets and de-risk it for big pharmaceutical companies are academic groups. So places like Mayo Clinic and other places. So that's why it's incredibly important to learn about the academic scientific progress in these areas, because that's where the pipeline is. That's where the pipeline for the next generation of therapies lie. So to cure diseases like Alzheimer's, we need precision medicine approaches. That's in my title. What is precision medicine? So precision medicine is diagnosing and treating the right patient with the right treatment at the right time. Currently, we're treating Alzheimer's disease as though it's a single disease. And I already told you, everyone gets Alzheimer's for their own set of reasons. So the way that we need to think about diseases like Alzheimer's and PSP is almost like cancer. Today, we're not talking about treating cancer patients. Rather, we're talking about treating brain cancer. And it's not just that, it's treating a specific type of brain cancer. And it's not just that, we stage it, we find its genetic markers, and we have specific, patient-specific therapies for cancer. That's where we need to be for diseases like Alzheimer's disease. And it's the research towards that that I'm going to talk about. So why precision medicine? Because I already told you, neurodegenerative diseases are complex. They're multifactorial, they're heterogeneous in their pathogenesis, in their clinical expression, in what we find in the brain as far as their signatures. We cannot diagnose them until it's too late, and they still remain a deadly epidemic without cures. So how should we think about neurodegenerative diseases? This is a model. At the top of the model are genetics and other genetic-related factors, epigenetics. The names don't matter. I'm telling you about the philosophy of it and the model of it. Genes by themselves is not enough. There's also a big emphasis now on environment, the exposome, where you were born, what you eat, what are your other risk factors, and education. What are the things that enrich your brain, and what are those that take away from your brain? Their relationship with genes, that matters. And this combination either puts you at risk for diseases like Alzheimer's disease or may protect you against it. And if you are at risk, there is a myriad changes in your brain, and these changes occur in different pathways, like your immune system, like your vascular system. Cardiovascular health is important in preserving our brain and other areas. And either the perturbations or the good things that maintain our brains have some biomarkers that we can measure. And these can be imaging biomarkers where we can measure the covering of our brains, how thick it is, the connections of our brains. It can be fluid biomarkers from the spinal fluid. You might have heard about getting spinal taps to diagnose Alzheimer's disease. And then blood biomarkers, which is the holy grail that help us not only diagnose, but predict these conditions. So this is the model that I'm going to talk about today. Okay, I'm going to give you the punchlines. So if you have a place to go after this, immediately after, you can leave after this slide, but we hope you stay. But these are the conclusions. I like giving my conclusions right at the start. The conclusions are that the current therapies and biomarkers for neurodegenerative diseases reflect only certain aspects of these diseases. They don't tell us about the full complexity. We need precision therapies and biomarkers that can reflect the complexity, all of the changes that occur in our brains. And we need to capture them in blood. There are very complex myriad changes in neurodegenerative diseases. That's why we need these precision therapies and biomarkers so we can aim the subtypes of these diseases. And we need to also keep in mind that Alzheimer's doesn't occur in a vacuum. There are comorbidities, heart disease, high blood pressure, diabetes. These are risk factors, and they are just as complex as Alzheimer's disease. We need to take that into consideration. And then we also need to find therapies and biomarkers for all of us, because you will find that much of this research is done in non-Hispanic white populations of European ancestry. And we know that diseases like Alzheimer's disease affect African Americans at twice greater risk and Latin Americans at 1.5 greater risk. So we have an obligation to study the diseases in all of us, including underrepresented populations, which I was talking to Karen in Florida, is the face of the nation in its diversity. So we have both an opportunity and an obligation to study Alzheimer's disease and bring cures, therapies, and biomarkers for all of us. Okay, so how are we going to do that? And what are the findings from the studies done at Mayo Clinic through our collaborations that I mentioned to you? So these are the results of those scientific studies, and I'll dive deeper, but these are the punchlines of those scientific studies. Both Alzheimer's and PSP have widespread perturbations in the brain. By studying the brain, we have an opportunity, a window into understanding these diseases. And I can tell you that at Mayo Clinic in Florida, we harbor the largest brain bank in the world of over 11,000 brains from donors who donated their brains for scientific research. So we have an opportunity to study that in depth. We can combine these molecular data to identify not just genes, but how they act. How are they beneficial to us and how are they detrimental to us? We need to combine brain studies with blood studies because brain isn't accessible until it's too late. We can learn from it, but we need to then bring it to our living patients, and that can only be done through accessible tissue, which is blood. Again, at Mayo Clinic in Florida, in neuroscience, we have hundreds of thousands of blood biospecimens from our patients that are deeply characterized. And so by combining the brain resources with the blood resources, we have this tremendous capability to understand the brain and then translate our findings to blood. Okay. So we're not going to go into the details of these studies, but you'll see some pictures acknowledging our team. By studying the brain and the brain bank, and by utilizing tissue and data from patients with Alzheimer's disease who generously donated their brains and patients with progressive supranuclear palsy, we had the very surprising finding that even though these two diseases are very different, one of them is like Parkinson's disease, the other is dementia. One of them is in younger patients, a drastic fast decline. The other is older patients and slower decline. And the brain signatures, some aspects are overlapping, but for the most part, they're different. What's surprising is that there are brain perturbations that are common to both of these diseases. Why is that important? That's important because that tells us that there are common pathways that affect both of these diseases, meaning we can join forces, meaning that findings in one can help the other one. So when we first found out about this, this was a major surprise, but now we find more and more about these commonalities. We can use these commonalities as an entry point to treating both of these diseases and potentially other neurodegenerative diseases. Also, we can use this vast genetic data together with samples and brain tissue and both protein, RNA, genes. We can combine all of these. Remember, I told you we know the general location of the fire, but not the house. Now we can get to the house by integrating all of that information. Not only that, but we can also get to how the house came to be on fire by combining all of these deep molecular information. Okay, so brain tissue is one of the most complex. No, I'll change that. It is the most complex tissue in our body. My husband might be mad at me because he thinks it's the liver, but we all know which one cannot be transplanted. Because brain is so complex, we need to understand these perturbations that I told you about at a single cell level. And we can do that by technological advances. At Mayo Clinic, I'm going to talk to you about this $41 million grant that we got to be able to map the brain at individual cellular level in patients from Alzheimer's disease and in controls. We can do it by utilizing that technology. We can also do it using analytic approaches. I'm sure everybody has heard of AI, artificial intelligence, machine learning. So that's some of the analytic approaches. We have others. And the point of this slide is that we are now able to get at single cell level type of brain perturbations by using both mathematical computational approaches and by using cutting edge technology. Okay, so this is Alzheimer's disease. This is progressive supranuclear palsy. This is other neurodegenerative diseases. We see the tip of the iceberg. There's much more to them. They're complex at the cellular level, at the molecular level, at the biochemical level, and neuropathology is complex. Clinical presentation is complex. Many patients with Alzheimer's disease, when we say Alzheimer's, we think about memory. Well, sometimes we have patients who come to us and they have visual problems. They've seen the ophthalmologist by the time they get to us. And then when we look at their biomarkers and do imaging, turns out they have an atypical form of Alzheimer's disease. So Alzheimer's is complex in many different layers. And it's important for us to harness all of this big data. But data by itself gets us only so far. We need to translate that data to knowledge. And that knowledge that I shared with you up till now showed us there's widespread brain molecular changes, that we can find genes and their variants, so the house and how the house came to be on fire. We can find cell-specific disease pathways. But that's still a ways to go from finding therapies and biomarkers. So what is the missing link? So the missing link is that we need to take all of this knowledge and prioritize it. We need to add layers and layers of additional evidence so that we may arrive upon a handful of top therapeutic targets, top biomarkers, to say we need to go after these. And at that point, we communicate with pharmaceutical companies, startup companies, so that we may bring them to the masses. How are we doing on time? Okay, great. We can do it in that time. So I'm going to talk to you about 2 studies as a proof of principle. How did we get from big data to knowledge to therapeutic targets that we're now working on and biomarker targets? So this first one is on progressive supranuclear palsy, and it's conducted in my lab. It's actually led by a PhD student at Mayo Clinic in Florida, because in addition to being a premier clinical center and a research center, we also have a lot of trainees, including a PhD program. Harry Min he's going to defend his thesis this June, actually went in, utilized all of these resources, the brain bank, looking at the molecular data, looking at single cell data to identify 3 therapeutic targets for progressive supranuclear palsy. And it's still early days. We're not calling it, we found the cure, but we need to do this type of studies to be able to get at a cure or set of cures. So how did we do that? In a nutshell, we utilized brain tissue, we processed it, we looked at it at tissue level, we looked at it at single cell level, and we didn't stop there. We wanted there to be more evidence. There are model systems, mouse models of these degenerative diseases. We put our findings through that funnel, and we didn't stop there. We said, okay, if we do this proof of principle study in fruit fly who get their form of this neurodegenerative disease, if we treat them, do they get better? Turns out they do. Now, the next steps are going back. So we went from human to mouse to fly. Now we're going back from that to human studies in iPSC cells, so pluripotent stem cells. Basically, we're generating brains in a dish from the patients, and we're going to be applying our therapeutic modalities to the brains in a dish. So very quickly, Harry found tremendous changes in the brain of patients with PSP. He replicated it at single cell level, and he then applied the sieve until he went from tens of thousands of genes to a handful of them, manageable number. This is exactly the kind of prioritization that drug companies are seeking, because it's too much to deal with tens of thousands of targets. It's even too much to deal with hundreds of targets. That's why academic centers have a role in this, a major role. And you see, just look at the lower right-hand corner, the left red image that you see, that's a good-looking fly eye, okay? It doesn't have the disease. The one right next to it has the disease. Look at the 3 next to them. It looks slightly better, and that's after we apply our approaches to our 3 targets. It's good for the fly, but we don't want to treat the fly. We want to treat the human. So what are the next things that we're doing? We chose a top target, a top therapeutic target. By the way, Mayo Clinic Ventures is also filed a provisional patent on this, so that's full disclosure, and we're doing further studies on it. We designed specific RNA, ribonucleic acid treatments against those targets. And this has some scientific information on how we designed them. But the bottom line, when we apply those ASOs, you may have heard of ASOs in the context of neuromuscular diseases. These are now utilized in the clinic. So there's an opportunity for us to use them in neurodegenerative diseases. So we designed a number of them, and we're going to be applying them to brains in a dish. And here you see all of that colorful pictures down there are how we can generate brain cells from patients' skin cells. So if a patient, if a doctor asks you, can you donate us a little bit of your blood? We're going to do research, or your skin. Please think about it, because there's a tremendous potential for us to be able to generate your brain cells from your skin. And that's what this slide is about. We measured the levels of those targets in these brain cells, and they exist. And now we're going to go towards applying our treatments in the brain cells in a dish. Very quickly, I want to talk about this biomarker study, because it was able to happen thanks to the Florida Department of Health funds that we got, that we use them as seed funds. And this study was done in patients that we saw at Mayo Clinic, patients of African-American background. It's a biomarker study, and we decided to look at this group of patients because they are vastly underrepresented in biomarker research. So we found some novel biomarkers that can distinguish Alzheimer's disease in African Americans. These are different than the traditional biomarkers being utilized, the amyloid and the tau. And in fact, so we developed a novel method to measure these biomarkers from blood at Mayo Clinic. And these biomarkers, these new types of biomarkers, increase the diagnostic accuracy of being able to say this patient has Alzheimer's disease by 7 or 8%. That may not seem like a big number, but even big genetic factors don't have far greater predictive potential, and this is the beginning. So we think that this is very promising. Based on this, we're now looking for markers of resilience, because resilience is the other side of the coin. Not everybody, Alzheimer's disease is not inevitable. We know this because there's a group of individuals who live to be above 80. So that's the tipping point for the highest risk for Alzheimer's disease. And they have the worst genetic composition possible. They're carriers of a gene, a risk gene called ApoE4, and yet they escape Alzheimer's disease. So we ask the question, why? How come there is this group of people, they're at risk, they don't get it. We want to find what they have so that we may develop things that can boost that it factor. And this is what that study is about. And this is done by a third-year neuroscience PhD student in my lab. So we went after these resilient people who live to be 80 and above. They have the risk factor, but they don't have decline. And we studied their blood. Turns out their energetics is different than others. They have genes in an energetic pathway that are higher than those who do get Alzheimer's disease. This is just a colorful picture telling us how we found many, over 40 different pathways. The one that stands out is the energetics one. And then we said, okay, the blood energetics pathway, is that preserved in the brain? Turns out that it is. So we can go from blood to brain. And then, and we did it in thousands of brain tissue. How are we able to do that? Not only because we have the largest brain bank, but we also have access to this very large amount of information because Mayo Clinic has been a leader in these large-scale studies. So this is from an AMP-AD study funded by the NIH. And there is tremendous correspondence of the brain and blood pathways in this energetics. And you see on the left, those are the energetics genes. You see how connected they are. That's a network, just like we are a network here. And that's a network of brain genes. And they are very tightly correlated with each other. We are able to then show that this energetics genes, they go up. When they go up, a person's memory is better. And the memory parts of their brain is bigger. Now, we don't know if it's the chicken or the egg. That's for us to do further studies on, but it is a biomarker of resilience. We confirmed it in mice as well. We confirmed it in multiple different mice models, and that's important because first testing has to start in animal models. And importantly, these energetics genes increase the diagnostic accuracy of Alzheimer's disease and an earlier form of Alzheimer's, we think, which is mild cognitive impairment, by 14 to 23%. That's huge. It's a potential blood biomarker of resilience that we can use. So I already showed you these, but I want to leave you with this study that was mentioned. This is the $41 million CLEAR AD grant awarded to Mayo Clinic in Florida and Indiana University School of Medicine to really identify the part of the iceberg that's in the ocean to find precision therapies and biomarkers. And it completely fits the framework that I told you about at the beginning of my talk. The expected outcomes are that we're going to find the precision therapies and biomarkers in multi-ethnic populations, so non-Hispanic, white, African-American, and Latino American. And at least part of the preliminary data that enabled this work came from the Florida Department of Health seed grants. So you see the return on investment there, which is essential. These are the principal investigators. The blue ones are from Mayo Clinic in Florida, because that's we have the color blue, and the red ones are from Indiana. We work very closely together. There's over 100 investigators that we're leading in this study across the globe, and they come from all 13 different institutions that you see up there. At Mayo Clinic in Florida, we had the first external advisory board meeting of all of these colleagues this year. And I want you to end with these words from Will and Charlie Mayo. I'll just leave it up there for you to read. But our purpose is one and the same, to heal the sick and to advance the science for all of us. So I thank you for your attention and your patience. I'm happy to take questions if there's time.
So we have time for a couple of questions. I think Larry's going to be first. Okay.
Much fascinating presentation. And we really appreciate the tremendous research that's going on, because Florida is ground central for all of this. I had two questions, if I may. You touched a little bit on artificial intelligence. Will you go into a little bit more depth about how AI can really help be able to analyze all the data that you have available to you in helping to move this forward?
Sure. So thank you for that question. I think, and I'll answer, but I think it's important to know that we have a new chair of Department of Artificial Intelligence and Informatics at Mayo Clinic, and she's going to be physically located at Mayo Clinic in Florida, leading all of the enterprise in these efforts. So artificial intelligence and informatics, they harbor tools for us to be able to manipulate really large data sets. Now, I alluded to some of the data sets here in my talk, but at Mayo Clinic, we have millions and millions of patient records, and we need a different type of an analytic paradigm to be able to ask questions of that data and to be able to find meaningful answers. So in a nutshell, AI and I is one very important approach, not the only approach, but one very important approach for us to be able to manipulate that data, harness that. By manipulate, I mean handle it, to harness it so that we may ask questions of it. It can give us predictive patterns, for example. We can train it using certain types of data and then ask questions in a different type of data. It has tremendous potential. At Mayo Clinic, we're using it in the clinical domain to enhance patient care, and we're also using it in the research domain.
Okay, very good. My second question is, obviously you talked about risk factors, and you talked about some of the physical factors, heredity, and obviously none of us can do anything to change who our parents were. But what tips would you give to people, lifestyle changes that are most helpful in helping to stave off some of these neurodevelopmental diseases?
Sure. So I think we can all do something about it, and that includes patients who have been diagnosed with Alzheimer's disease. I tell my patients, and I did tell Harvey at the podcast also, it's a terrifying diagnosis to receive, and it's a very sad diagnosis to give. We don't have a cure, but I think we can be hopeful in a data-driven manner. And what is the data? The data shows us that there are multiple different approaches that we can each apply in our lives, whether we're cognitively unimpaired or whether we do have these diseases, to maintain our brains in the best shape for as long as we can. Some of these have to do with cardiovascular risk factors. So it turns out that if you reduce your cardiovascular risk factors, that is also good for your brain health from a dementia standpoint. So blood pressure and make sure that if you have diabetes, it's addressed and these kinds of things. Also, the exposome, what we eat is part of that. So increasing fish in your diet, increasing antioxidant foods, so foods that boost the energetics. Remember, I told you about the role of energetics as a potential protective factor. So a handful of nuts and berries and things like that, that's important. Also important is engagement, and that's cognitive, physical, and social engagement. So we're all doing social engagement here. And that's great for us to maintain connected. There's a relationship between social isolation that many of us experienced during COVID with adverse effects on our cognition. So social engagement is important. Physical activity is important. There is always discussion on how much. So the current recommendation is 150 minutes of brisk walking per week. Is good for you. And then cognitive engagement, we're all doing it here. And yesterday we were talking about different types of cognitive engagement, and music is one of them. So if any of you are singing, or it's not too late to take piano lessons or be part of these activities, there's a tremendous benefit to that at many different levels. Sleep is an important one. Snoring is not just annoying to the partner, it's annoying to the brain. And so looking for identifying and treating sleep apnea, that's going to be important. And then mood, something that we may not always talk about, depression, anxiety. These are diagnoses just like a headache, for example, and they need to be addressed. Sometimes these come with a stigma, but keeping our mood in optimal shape is also important.
Thank you very much.
You're welcome.
Marnie, the last question.
Thank you very much for your presentation today. It was very interesting to me. My mother passed away of Alzheimer's. So obviously one of the things that I would typify would be she forgot even how to eat. So if you could talk a little bit about what are some of the things that get affected. But my second question though is, you didn't talk about where the genesis of this came from. Is this something that modern man has seen? Has it been around for a long time? We just haven't diagnosed it. How come we're seeing it explode now? Is it environmental? Is it genetic? Is it a little bit of both? Thank you.
Excellent question. So I'll start with the second one. Also, Harvey asked the same question. So Alzheimer's disease, as a distinct disease with a signature in the brain, was diagnosed over 100 years ago by Dr. Alois Alzheimer, who found these plaques and tangles and drew them by hand, actually. But the disease, in the clinical sense, came to be recognized as such much, much later. And the reason for that is because for a very long time, it was thought this is part of normal aging, that it's inevitable. Senility, these are some of the names that was given to Alzheimer's disease. Only in a little over half a century, did we come to recognize that this isn't normal aging. I told you about the super agers, those above 80, and they don't get cognitive decline. So the reason why we're seeing an explosion is, one, because we didn't recognize it as such, and it's more recognized now. Two, there is a tremendous increase in the older population, especially after the baby boomers. We live longer, and there is more of us who live longer. And this is a disease, not exclusively, but predominantly a disease of aging. And the third reason is, despite this increase in longevity and the increased numbers of people who live long, we still don't have a cure And it is a gradually progressive disease. So there's a long period of time that individuals live with this condition. So those are all reasons why it's so common, so very common. If you feel comfortable, show of hands who know of someone close who has Alzheimer's disease. Right. So, the second question pertains to caregiving. What can we expect? So it is a progressive disease. So we expect that patients' symptoms are going to get worse with time. And a very common question that I get is, how many years, doctor, for my mom, for my spouse? And I tell them, I don't know. And nobody knows, because as I told you, each person gets Alzheimer's disease for their own set of reasons. Each person has their own course. We know it's progressive, but I can tell you that I've had patients whom I followed over a decade, and they're okay. And then others who succumb to this disease in a matter of years. So a good rule of thumb is look back 5 years. Where were you now? Where are you now? It might be an indication of where things are in 5 years. But even that's not accurate, because we now have a new drug, for example, that targets this amyloid in the brain. It's not the silver bullet, but it is the start of more to come. So I think we can be hopeful from that standpoint. We should have measured hope about that, and a lot of hope for what's to come next. Having said all of that, caregiving is a major issue. The resources that we have for caregiving are still not where they're supposed to be. And there is the caregiver burden is a major and relatively under-recognized issue, that caregivers themselves have greater health problems, et cetera. So we need to have more resources for research so that we may cure these conditions. We need to have more resources to be able to predict, prevent, diagnose these conditions. In parallel, we need to have more resources for caregivers as well, and also more resources for education in this realm.
Come back, Dr. Ertekin. I just want to say, well, when you first told me this was going to be a scientific presentation, I was a little intimidated, but you said for highly functioning lay people. So you have a tremendous gift of taking a very complex subject and making it understandable. So thank you for that. And please accept this token of our appreciation.
Thank you so much. Thank you.
So as we close out today, please be on the lookout for details about our May member meeting, and this meeting is now adjourned. Thank you.